Let us consider an object, let's say a 5 kilogram mass. Whatever this object may be, we can simply represent it as a 5 kilogram box. Now in space, far away from anything, there are no forces acting on. To explain the motion of any object, we call upon Newton's 3 laws. In this case, as there are no forces acting on the object, we call upon Newton's first law. Newton's first law of motion says that it will stay stationary if it was stationary, or move with a constant speed in a straight line if it was already moving. Now, if the object was at rest on Earth on a table surface, then the gravitational force will pull it downwards. Show this with an arrow downwards, F gravitational. And the table will push it upwards with a normal reaction force due to Newton's third law. The gravitational force can be found by the equation weight, or F gravitational, equals mass times G. The mass is 5 kilograms, G is always 10, and so we find 50 newtons for the gravitational force. In this case, the object is stationary, so the normal reaction force will also be 50 newtons. Since the forces acting on the body now are balanced, Newton's first law continues to hold. Since the body is stationary, the body will continue to remain stationary. If an external force is applied to the body, then the object will have a net force. Again, we call on Newton's laws to explain its motion. Newton's second law predicts it will accelerate. If the applied force in this case is 100 newtons, then the net force will be 100 newtons. The acceleration of the object can be found by using the Newton's second law equation. Newton's second law equation says that the acceleration depends on the net force and the mass of the object, and are related by the equation A equals F net divided by mass. In this case, the F net is 100 newtons, the mass is 5 kilograms, and so the acceleration of the body is 20 meters per second squared. This is without considering friction. In the case the body was moving, there will be a frictional force. Let us say the frictional force is 40 newtons. Now, frictional forces act to oppose the motion of the body, so if the body were accelerating to the right, the frictional force will be acting to the left. Since the body is now acted upon by two forces, an applied force of 100 newtons to the right and the frictional force of 40 newtons to the left, the net force is now 60 newtons. Again, we can apply Newton's second law equation to find the acceleration of the body. Acceleration equals F net divided by mass. In this case, F net is now 60 newtons, the mass is still 5 kilograms, and so the acceleration is now 12 meters per second squared.